Hi and welcome to India IT 360's Leader Tech Tea. I am Divya Giri, your executive editor and host at India IT 360. So today we have a privilege of having a conversation with the top-notch CDIO of Essar Capital, Mr. Vinod Sivarama Krishnan. Hi, sir. Welcome to the show, and thank you so much for joining us today. And how are you?
Thank you so much, Divya. It's my pleasure to be here.
So I would like to tell my audience that today we are going to have a discussion around IoT, like its perks, its cons, and how it's going to affect the IT industry. And also we're going to talk about the future things like how it's going to affect it. So before we start, sir, can you tell us something about your professional journey?
Sure, I'd be happy to. I have over 30 years of work experience, and it's very, I think, instructive that every day of my work I've been in charge of information technology.
Okay.
So I've always been working on the corporate side of information technology. I've never worked for a company that is actually in the IT services or IT product sector, but always working for businesses in implementing IT and digital.
Okay.
Among other companies, I've worked with a Fortune number one, a
Okay.
Fortune number six, so in the form of Walmart, in the form of GE, and in- uh, and with a number of other companies over the years. In fact, I worked in about 14 different domains
Yeah.
and industries over the years. And I'm currently with Essar, which is a large diversified group with many interests in core engineering and industrial.
Got it, got it. So all the knowledge from brands and all got churned up together, and it is you who are having conversation with us. It's again a pleasure. So, sir, before we move forward, so that I have few questions like around IoT, like what is the Internet of Things? How do you envision IoT technology transforming business operation, and what steps should be taken to lead this transformation?
Okay. So I think, when you look at it, it's most simple. The Internet of Things is really about connecting devices or connecting equipment to the internet.
Okay.
Now, for a long time, the expectation of connectivity, at least in the years that I've been working in the field, was about connecting people. But I think, the idea with the evolution of technology, the idea is now that you are collecting data
Yeah.
and you are connecting machines. And,
Yeah.
and that is really what the Internet of Things is all about.
Hmm.
Now, obviously, when we talk about connecting devices, when we talk about connecting machines, suddenly we talk about a much bigger scale of connectivity than we've ever talked.
Okay.
Because while we might be only 6 billion people on this planet or 7 billion people on this planet,
Yeah.
there are certainly more machines than that. And therefore, it's an exponential rise in the points of collection of data. It's an exponential rise in the data itself. Has all sorts of interesting impacts on, for instance, data storage, for instance, analytics, and for instance, of course, the buzzword of today, which is artificial.
Got it, got it. So, sir, moving forward with the question, so what strategies should be implemented to ensure the security and privacy of IoT devices and data within an organization?
So it's a good question because once you start getting into device collection, the question is really what is the necessity. Now, obviously, when it comes to security, at least my own viewpoint has always been that, there's always a cost to security. And the question is at the level at which data is coming, is there any relevance? How significant is it that you lose data? So I'll give you an example that in my days at Walmart,
Okay.
I used to ask my store managers that aren't you worried about availability? That if I tell somebody that this store has this availability, isn't that a big problem for you? And my store managers taught me something that I've not forgotten, which was they said, no, I don't care if anybody knows it.
Okay.
And I said, why? Because this is something that is changing all the time.
Yeah.
I don't know that, somebody will be able to tell or do anything about it in real time. So I think there's a very fine balance that we have to achieve between protecting and, of course, we should not permit, for instance, fake data to come.
Hmm.
We should not permit rogue data to come into the system.
Hmm.
But how we will protect ourselves against the multiple sources of data is a strategy that we have to work out very carefully based on the value of that data
Hmm.
and the criticality of the data to operations
Hmm.
of my company. For instance, if a piece of data is going to make me do something automatically, like I get some temperature data and I decide that there's a fire there and I want to turn on the sprinklers.
Yeah.
And I want to be very sure that there's a fire before I
Hmm.
turn on the sprinklers.
Hmm.
Then it becomes very important for me to secure that pathway of that data. It becomes very important for me to secure the places where I'm collecting it from and to know that it's not fake.
Yeah, and also when it comes to like organizations, you have to be more conscious about it.
No, absolutely. And the other part is really that look, if you have a number of data points, like for instance, sensor data,
Mm-hmm.
it's always known that sensors, especially at large numbers, will be individual sensors that will give you wrong data.
Yeah.
Things will go wrong.
Yeah.
But then you have the power of algorithms to actually smooth that data and say it's not possible that, these three sensors are saying something, but this one in the middle is saying something else.
Yeah.
Perhaps it's not. So when you
Mm-hmm.
apply those techniques, I think you have a much better chance of protecting against,
Hmm.
missed data or protecting against wrong data. And I think that you should take your security considerations
Yeah.
along with what you're doing with it.
Hmm. So, sir, what are some potential IoT applications or use cases that would have the greatest impact on our industry or organization?
So the biggest one, particularly for the heavy industrial
Hmm.
kind of businesses,
Okay.
which I represent in many ways because many of my domains are there. The biggest use case is obviously predictive maintenance.
Yeah.
And the reason for that is very simple that a lot of businesses are really asset business,
Hmm.
or equipment businesses. And
Yeah.
now the biggest problem with equipment is that it fails.
Hmm.
And when it fails, there are immediate consequences. Think
Hmm.
of an assembly line, think
Yeah.
of earth moving equipment. So the idea is really that in all 100% of cases, prevention is cheaper and better than a cure.
Hmm.
And the problem with conventional programming in these areas is really that
Hmm.
it's not a linear equation
Hmm.
between two or three variables that you can say that if this happens, this is.
Yeah.
Otherwise, we would have solved this problem
Hmm.
years back. It
Okay.
is that there are about 100 variables, and each one of these variables is interacting with each other in a way that you don't understand.
Hmm.
So,
Hmm.
till now, we had two problems. We didn't have the data and we didn't
Hmm.
have the tools to work with it.
Okay.
Now, you have real time data which is coming from IoT, and now you have AI which is creating those deep learning and machine learning models at the back end with this
Yeah.
data.
Hmm.
And now, the combination of these two is giving you that result which says, look, for
Hmm.
instance, if you looked at the
Hmm.
basics of AI, you'll
Yeah.
see that many of these models don't explain how they're doing it. There's no
Hmm.
equation.
Hmm.
But simply by looking at the power of patterns and the power of big
Yeah.
data, they're able to do a very good job of predicting that if these conditions are fulfilled, then this is going to happen. This machine is going to fail, and you better pull it out of service right now
Hmm.
and overhaul it or do whatever you need to do to it to avoid the fail.
Hmm.
And that is really, what has changed in our industry is that you have the availability of real-time data, which you never had,
Hmm.
streaming data.
Okay.
How typically we used to operate in the good old days is that when the machine goes down,
Hmm.
then you find out and then you go out and do something about it.
Hmm.
Because you didn't have the bandwidth to measure what was going on in that machine just before it failed.
Exactly. Exactly.
Even when you did, you didn't have it in any meaningful time that you could do anything about it.
Hmm. Hmm.
For instance, it's no use if 2 minutes before a machine is going to fail, if you know it's going to fail, it
Hmm.
doesn't help you because there's no possibility of an action.
Hmm. Hmm.
Now, what has happened is you understand well enough when you set your threshold and you say, okay, I want to know 45 minutes before an outage of the million outages that I have, 45 minutes before that, I want to know what are the conditions that are likely to predict it.
Yeah.
And let's say I'm able to achieve a 90, 85% accuracy in predicting those outages.
Hmm.
That means that I can cut down 90 or 85% of my outages.
Yeah.
which may sound like not a very perfect number, but it's a very huge number when you're already operating at 99.9 or
Exactly.
99.6.
Exactly.
Coming to 85% of that point four is a holy grail. And companies will invest and pay for that.
Hmm.
So that
So,
is, to my mind, the biggest use case.
yeah, yeah, that's true. So, how would you integrate IoT data with our enterprises system and analytics platform?
You see, there's only two places where I really think you need to integrate. One
Okay.
is you have a data, you have an analysis, you have a call for action.
Hmm.
Technically speaking, this can be a standalone.
Okay.
But this call for action needs to go through your systems,
Okay.
right? Because you have operating systems. So I'll give you an example that you have a machine. To go back to my previous example, you have a machine that's going to fail in 45 minutes.
Yeah.
Now that alert has to go into your field force management system to a
Hmm.
technician. It has to be assigned to a technician as a ticket. The
Yeah.
technician has to take it up. He
Hmm.
has to go and do it. He has to go and record in the system that he's replaced the part or whatever he did.
Hmm.
And then he has to get paid for that. So all of these processes.
There's a process for.
Exactly. So the problem is that with the signal, you can be standalone.
Yeah.
But when you want to do anything about it in the practical nature of an organization, of course you have to. For instance, I got an input. Now, what do I need to do about it? Often the action that has to be taken is a ticket has to be assigned to somebody, somebody has to do.
Hmm.
But it could also be a financial thing. I have to place a purchase order. I'm running out of supplies on this. The oil level here has gone low.
Hmm.
I need to order this part. I need to order this
Hmm.
uh, in time
Hmm.
so that I get it.
Got it.
So these are all actions that you do from your regular enterprise system. So obviously there has to be a big interlock in terms of the action translate. That's one side of it.
Yeah.
The other part is really that, for instance, when I'm sourcing, let's say I'm buying it,
Hmm. Hmm.
and my data is telling me that this particular brand of equipment in rainy weather it fails all the time,
Hmm.
whereas the other brand is working very well.
Hmm. Hmm.
Somewhere in my enterprise system, when I'm ordering a new equipment, if
Yeah.
I'm ordering it for a place that has rain, it should flag to me that this is probably not the right choice. So I
Yeah.
need to integrate that data back into that logic has to come back into my enterprise systems. So
Hmm.
these are two places from an enterprise systems point of view. From an analytics point of view, my own view, and this is perhaps a little controversial, is that
Hmm.
the value of the data is not so much in the analytics as much as the outcomes it gives you.
Okay.
You can do your analytics, but the possibility that you will take IoT data and you will do analytics apart from the
Hmm.
deep learning or the machine learning models that you've done, I don't see that as a big. I mean, it's a good thing to do, but I don't see that as a big payoff area.
Okay.
I think your analytics should be again around things that you can drive actions from.
Hmm. Hmm.
No, if you're driving a car, the speedometer is telling you how fast you're going. There's
Exactly.
an action. You either slow down or you speed
Yeah.
up.
Yeah.
But if you're just seeing, okay, the temperature of the engine is 10 degrees, it's not really going to make a difference in it.
Exactly.
So I
Hmm.
think you have to be again very careful because these are huge volumes of data we're talking about, and the analytical tools that handle those huge volumes of data are expensive and difficult.
Hmm.
So you have to be sure that there's a payback in the analytics on that data before.
Yeah. So, what are some key considerations for building a scalable and flexible IoT infrastructure that can adapt to emerging technologies and changing business needs?
Yeah. So typically, what you have to do is you have to make sure that you don't disturb the field too much.
Yeah. Mm.
So I think your devices, your data collection points need to be very robust.
Mm. Mm.
Now, a lot of people look at sensors as the answer to everything.
Mm.
But I think there's a great amount of value to be had without sensors also, which is the core data that comes from a machine.
Mm.
Right. For instance, somebody puts a sensor on a machine and says the temperature of the outside casing is so much.
Yeah.
That has value, but it may not have as much value as just understanding what the current is, what the voltage is, what the consumption is. And
Mm.
at one level, these are simpler data points, but I think the value is all there. I
Yeah.
think you can get additional value when you go to the
Hmm.
So you have to really build this in stages. I think first you have to get the basic data that you need,
Hmm.
understand how to use it, optimize it, and then layer on and be very careful about every data element that you add to the mix.
Hmm.
Because when you start collecting it, you'll have to store it, you'll have to bring it into your analysis, you have to bring it into your modeling, and all of these things will cost you money.
Yeah.
To understand if there's a value to do it. I think
Hmm.
one consideration is really what are you getting, what are you
Hmm.
trying, what's the problem that you're trying to solve.
Hmm.
And that is what makes it scalable. The other part is once you get it, the
Hmm.
question is how do you optimize? For instance, now you built a model, you trained that model.
Yeah.
Do you need to keep training that model for the
Hmm.
same use case, for the same kind of equipment? I think after a point you say, okay, no, I'm reasonably clear that this is my functionality.
Hmm.
Then you work on optimizing your hardware,
Hmm.
software, and
Hmm.
services footprint to
Hmm.
maximize the return from that use case.
Yeah.
After a point, your further modeling is not going to add any significant value to your use case that you
Yes.
started with.
Hmm. Hmm.
So I think those are two things that if you keep in mind
Hmm.
once you've done your original model and once you have a mechanism to look at its efficiency,
Hmm.
once every few months,
Yeah.
then I think you really need to optimize it. And
Yeah, that's true. So, what does you say on balancing the potential benefits of IoT adoption with the potential risk and challenges such as increased complexity and cybersecurity threats?
in general, look, this is complex. There is no, two ways about it. But I think there is a high degree of complexity
Yeah.
when it comes to IoT projects. I mean, because partly because most of these independent activities that you do are all expert
Yeah.
collection of data.
Hmm.
You
Hmm.
know, so the device itself or the meter or whatever it is that is actually generating that data, the measurement data. Then the
Hmm.
second part is the transmission or the backhaul of the data to
Yeah.
the cloud or your data center. That is two
Hmm.
is a big variable. The third is okay, once it gets to your cloud or data center, how are you organizing it? How are you storing it? How are you
Hmm.
manipulating it? How are you cleaning it before you get it into your model? How are you bringing it to your model?
Yeah.
Then, of course, is the model itself, and we talked about that just now, where I said that you have to optimize that model, and
Hmm.
after a point in time, you have to stop
Hmm.
disturbing it.
Yeah.
Then comes the action that comes out of that model,
Yeah.
and how it comes into your enterprise systems, and how it is a trigger to action. And
Hmm.
then, obviously, after the action is over, is the measurement of how has this performed? What is it
Hmm.
driving for you by way of business outcomes?
Hmm.
So in the complex chain, I think the idea really is to say that the challenge is really that to get it right, you have to get each one of these pieces right.
Yeah.
When one of these pieces, if you get wrong,
Hmm.
you decrease the value of the overall project.
Hmm.
You cannot afford to be an analytics expert or a modeling expert or an AI expert and come into this and say
Hmm.
all the rest is taken for granted. That's not how it works. You have to get
Hmm.
each piece of this right, and that's the biggest challenge.
Hmm.
But in truth, this is also the holy grail for all industrial companies
Hmm. Hmm.
because the problems that we are now trying to solve with real-time data are problems that we've had from years.
Hmm.
We've grown up accepting that these problems can't be solved, even though
Agree.
we understand that they are a very high cost to the business, a very high customer experience. We've
Hmm.
always believed that. So solving these problems will take us to a new normal in terms of customer service, to a
Hmm.
new normal in terms of reliability, to a new normal in terms of cost effectiveness.
Hmm. Hmm.
And the promise is huge.
Hmm.
I believe that no matter what the constraints are, no matter what the challenges are, it's worth pursuing this. But I think we have
Hmm.
to be very realistic and say it's
Exactly.
a very long haul and has to be done
Hmm.
very well in order to deliver the outcomes.
Hmm. Got it. So, what metrics of KPIs would you use to measure the success of IoT initiatives, and what benchmark would you set for ROI and return on investment and other outcomes?
Okay.
Yeah.
So, I've always been a big believer that there should be no other metrics other than the business metric.
Mm.
So, if you're in a sales
Mm.
function, then the metric is sales.
Mm.
If you're in a optimization of service costs or outages function, metric is cost. The metric is cost avoidance. The metric is uptime. So,
Mm.
there is no IT metric really for a
Mm.
IoT program.
Yeah.
However, if one would have to actually force
Mm.
a metric on this, it would obviously be the effectiveness of the model,
Mm.
which is to say that what was your pre level of pre IoT level of
Mm.
failures or outages or
Mm.
disruptions versus what is your post,
Yeah.
and to have some measure of what is the cost of outage so that you understand whether the program is making money or
Mm.
not. Now, one thing I'd like to say is that many of these problems are solved one time.
Mm.
So your investment is actually one time, but your saving is perpetual. Now, unfortunately, we don't normally look at it that way. We say that okay, this is going to save us, let's say, 100,000 a year, and if
Mm.
we spend 500,000, we say payback is in 5 years. What we don't see is that payback is indefinite after,
Mm.
right? If you look at what it costs to maintain this relative to these
Exactly.
savings,
Mm. Mm.
this is a win-win from the day zero. So I'm not a big believer in looking at ROI in the
Mm.
sense in which we look at it.
Yeah. Mm.
Having said that, I think in order to obviously get this project approved at a
Mm.
board level and all of that, you obviously have to look at what is the number of years it will take to pay back
Mm. Mm.
initial investment. And in my view, this is a technology and these are investments that are huge. So
True.
we are talking about a typically 3 to 5 year payback
Mm.
period for this technology. I think if we can land up anywhere between 3 and 5 years, I think we are in a very good place because the kind of problems we are solving are problems that nobody has solved.
Okay. So, sir, what do you think is the future of IoT in the context of India in the next 5 years?
Okay, so I think look, there is unlimited scope.
Yeah.
The problem obviously with that unlimited scope is how do you prioritize, how do you manage that, how do you implement
Yeah.
it right.
Yeah. That's
One
also
thing,
important.
one thing which is very clear is that when this started, we said, look, it is
Mm.
a number of things have evolved very, very fast in this landscape.
Mm.
Let's start with basic things like reliability of the devices and sensors.
Mm.
Previously, sensors used to be expensive.
Yeah.
Sensors used to be very unreliable,
Yeah.
especially because they are often exposed to the
Mm.
huge variations in temperature
Mm.
or moisture. they
Mm.
they interact with nature.
Yeah.
That is the nature of the beast. And previously they were expensive, they would get spoiled, they would get corroded, things would happen to them.
Mm.
Obviously the price of sensors have come down
Mm.
tremendously. The reliability of these sensors have gone up tremendously. So obviously there's been huge improvement in that. So
Mm.
now it is much more likely that we would invest in, let's say, if you looked at CCTV cameras, for instance.
Yeah.
I'm sure we all can relate to the idea that you never see them, and now you see them
Yeah.
everywhere.
Exactly. Exactly.
And so the idea is really that your devices are proliferating one level, and
Mm.
I think that is going to continue to happen. We're going to have cheaper sensors, we're going to have better sensors, cheaper meters, better meters.
Mm.
Second is connectivity.
Mm.
One of the biggest problems was always how do you get this data back? Because you're talking about collecting it from a remote site or collecting it from a mine or collecting it from an oil well or something or from a ship. How do
Exactly.
you bring it back? And
Mm.
now you all know with 5G, with
Mm.
potentially future generations of telecom,
Mm.
connectivity is almost universal. The kind of
Mm.
bandwidth you get today in a remote site,
Mm.
even as recently as 3, 4 years back, we couldn't think of that kind of bandwidth,
Mm.
at a remote site. But now we can, and we're seeing
Mm.
it. Connectivity is.
Mm.
Thirdly, our ability to store data. You look at the number of platforms, the big data
Mm.
solutions, the Hadoops of the world, the Google Clouds of the world, the Azures of the world. we didn't have these kind of platforms to be able to assimilate huge amounts of data and to be able to actually, reasonably manage to store them and process them. And then, of course, you have AI, which has suddenly become very
Exactly.
interesting to everybody. And
Exactly.
now you have more people who understand how to use ML algorithms, how to build models, how to validate models against, particularly against sets of industrial data.
Yeah.
So, I'm tremendously excited because a number of factors are coming together.
Yeah.
And we've never had as much reliable data. We've
Hmm.
never had such reliable telecoms. We've never had such reliable backend database platforms. We've never had such reliable models to work with things. So when you take these together, I think, look, the sky's the limit when it comes to what will happen. I see that the demand for IoT will be fueled by the good successes that will come and models, the good use cases, because when you crack this, it's a tremendous competitive advantage.
Exactly.
You're an airline and you crack this, then everybody else will be chasing in the industry this thing, and obviously, to my mind, it's a little bit of a competition out there now to say who can get their act together in every industry. The first person to get their act together is going to get a huge, huge advantage. So it's a little bit of a race there. Of course, in this race, some people will overinvest, some people will do things that they don't need to do. That is natural. In the next 5 years, I really see the proliferation and the collection of data and proliferation of models across all the four areas that I spoke about. You'll see a lot of growth,
Exactly.
very, very explosive growth. And some of these we'll have to scale back when we find out paying off. But there will be huge competition for people to find the right models in the industry. That is at least my view that today there is no possibly hotter market.
So, sir, thank you so much for joining us today. And the best part, what I liked when I was having a discussion, you were showing each and every answer with an example, which was very easy to understand and easy to grasp. So, I hope you guys also found our discussion insightful and inspiring. Stay tuned for more exciting conversation with industry leaders. And remember to follow us for the latest updates and insight. Don't forget to subscribe and stay tuned for more.